Hello everyone, and welcome to the last video in this video review series for the entirety of the AP Stats exam. This video today, we're going to cover the linear regression T test, the very last topic in the course and exam description. And so in the previous video, we covered linear regression T intervals. In this one, we're going to dive into the hypothesis testing side of things, which is almost identical, just your formula changes a little bit. So let's jump right in. Now, the whole point here, again, hypothesis test versus confidence interval, is we're looking for evidence of a correlation. That is the idea. The residual plot is cool, but the hypothesis test is stronger evidence that we have a true linear relationship between these two variables. Before we jump into the formula, one thing that's very important is that your hypotheses are always going to be the same. This beta here represents the true slope of the regression line. And so, for our hypothesis test, we are always going to have a null hypothesis and assume that we have no correlation or a slope equal to 0. And for our alternative, we're always going to be testing not equal to 0 for two reasons. One is that we always set the hypotheses before the data is collected. And so I don't know if this data set could potentially have a positive correlation or a negative correlation. The other reason for that is that being able to reject a two-sided test like this is even stronger evidence than a one-sided test, because you need to be further away from the center in order to have evidence as we split your significance level onto both sides. So that's one important thing. I also say that because now your test statistic looks like this. It's B1 minus 0 over the standard error of your slope. Now, if you remember from the previous video, this is just the slope from your sample. This 0 that we're subtracting comes from the null hypothesis, and obviously this standard error comes from the printout. Other very important thing, we still have n minus 2 degrees of freedom. So the formula is very simple. Oftentimes you will see this simplified as just the slope over the standard error of the slope. The reason that it is still written this way is that potentially in something like a question 6, they may switch these hypotheses up and you may be testing against one specific number instead of 0. Right? They may change the hypothesis test to be a little bit more specific, where someone hypothesizes that the slope is 5. Do we have evidence to disprove their claim? As opposed to just, do we have a relationship? So, what's the process? Very importantly, it's still HAT North Carolina. However, very similarly to before, these are all my assumptions. Notice that these assumptions don't change from the confidence interval ones. They are exactly the same, and very similar to confidence intervals, you're also most likely going to get that sentence of assume all conditions are met. And if you don't see that sentence, what you will probably get is a question about which condition is violated. And almost always it is that constant standard deviation, right? That the standard deviation of y does not vary with x. That is almost always the condition that is violated. You'll get a residual plot that fans out or fans in or has a clear, distinct pattern, something like that. But let's take a look at an example problem that is from an FRQ. And so, for this particular one, this is about windmills generating electricity. And now here, I only took one part of the question. This had A, B, C, D. I only took part D because that is the one that involves the hypothesis test for slope. And I have this whole thing here. Prior to this, in this question, I believe it says, Yep, it says it right here. The regression model assumptions were checked and determined to be reasonable over the interval of wind speeds represented in the data. Right? So that is my equivalent of assume all conditions are met. And now, I'm not going to go through and do the whole hypothesis test here because you don't actually have to. Is there convincing evidence of electricity production? If I take a look here, this is my slope, right? This row represents my slope. I have the coefficient, I have the standard error, I could do the division, but everything I need is right here. The T column is your hypothesis test. This right here is the test, and this right here is the p-value. So for this particular one, and almost all of them look like this, I get a t-value of 12.63, a p-value of 0, which means I have statistically convincing evidence that there is a linear relationship between wind velocity and electricity production. These are so incredibly simple if you know where to look. So, in signing off for the final video here in this review series, I hope that you got some value out of all of them. I truly appreciate you guys watching these. Good luck on the AP exam.